In this video, we'll take a close look at a water sensor, examining its design, how it detects moisture, and the principles behind its operation. We'll also cover practical ways to use it in different projects, demonstrating setup, calibration, and tips to get the most accurate readings. Whether you're building a smart irrigation system or a flood alarm, this guide will help you understand how to effectively incorporate a water sensor into your own projects. So let's dive right into it. First, let's take a look at how this module actually works. A water sensor is typically a straightforward component used to detect water presence, measure water levels, or even monitor soil moisture. Water sensors generally consist of a small PCB with two main parts. The first part is a sensing area, and the second part is circuitry and signal output. These sensors typically consist of 3 pins, which are the VCC, GND, and the signal pin. Sensing area is a series of conductive metal traces arranged in parallel, typically on one side of the board. When water touches the sensor traces, it creates a bridge between them, altering the resistance and allowing current to pass through. The higher the water level, the more traces get covered, and the analog reading changes accordingly. Now we can proceed to connect this sensor to our microcontroller to start detecting water presence. To connect and use this module, we only need some jumper wires, and that's it. There are only 3 pins that needs to be connected. We will start with the GND pin. Next, connect the plus pin to the 5V pin on the Arduino and the S signal pin to any of the Arduino's analog input pins. With everything connected, we can move on to writing the code for this project. The first step is to declare the pin we'll be using for the sensor, and in here, I'll use the pin A0. Also, we will create another integer variable to store the values received by A0 pin. In the setup method, we simply need to initialize the serial monitor. This will allow us to print and view the sensor's readings in real time. In the main loop, we'll use the analog read function to read the signal from pin A0, then store this value in a variable. And at last step, we will print the signals received to the serial monitor. Lastly, we'll add a short delay at the end of the program loop. This will help stabilize the readings and make the output on the serial monitor easier to read. Now we can upload the code to the Arduino and observe the results. I'll place a drop of water on the sensor to observe how the values change, giving us a real-time view of the sensor's response. As I apply more water to the sensor, you can see that the values are increasing, indicating that the sensor is effectively detecting the moisture. And when I dry the sensor, the value will go back to 0 again. Now I'll put the sensor in a glass of water to observe how the values change in that environment as well. As I immerse the sensor deeper into the glass, we can see the values continue to rise, demonstrating the sensor's sensitivity to water levels. Now we can take it a step further by creating an alarm system to indicate the water level, enhancing our project with an additional layer of functionality. I'll use a buzzer to signal when the water level exceeds a certain threshold, along with 3 LEDs to visually represent different water levels. We also need to add additional lines of code to accommodate the new components we've introduced. As always, the first step is to declare the new pin variables for the LEDs and the buzzer in our code. This will allow us to easily reference them later on. Next, in the setup method, we will initialize all these pins as output. Finally, in the main loop, we'll use an if statement to determine when to turn on a specific LED based on the water level values received from the sensor. For example, when the value is between 0 and 70, we can turn on the green LED to indicate that everything is normal and the water level is safe. For the yellow and red LEDs, you can implement your own logic based on the water level thresholds. Just remember that when the red LED is activated, the buzzer should also sound to alert us of a critical water level situation. Now let's upload this version as well and see the results. If you enjoyed this video, please give it a thumbs up and consider subscribing for more exciting tech content. Your support helps us create more videos.